This is Dr. J. Mohan from EC Department of Institute of Aeronautical Engineering. Today we are going to discuss about the Trigonometric Fourier series with example in my subject of signals and stochastic processing. Today presentation outline is Trigonometric Fourier series, Dirichlet condition for the Fourier series, alternative notation for the Dirichlet condition and Fourier series, exercises and reference. First we go for the Trigonometric Fourier series. In this Trigonometric Fourier series, we should take for the orthogonal signals. So in this orthogonal signal, I should take for the two different kind of signal. One is represented as sin n omega 0 to t and sin m omega 0 t. These two signal, it will be have the n harmonic and m harmonic, it's present together. Both of them, it's going to work with the different kind of vector cases. So this different kind of vector case, we concluded that orthogonal condition. So in this orthogonal condition, each signals sin n omega 0 t and sin n m omega 0 t, both it's going to work as a t0 to t0 plus 2 pi by omega. This signal, it will be represented as a periodic signal. That periodic signal, it's a fundamental period capital letter T. This T only is present the interval of t0 to t0 plus 2 pi by omega cases. So if we go for the orthogonal set, then we concluded for the signal as omega 0 t and sin omega 0 2 time of t from as a orthogonal condition. This set is not a complete without cos n omega 0 t. Because of this, cosine set is also orthogonal to sine set. We should complete this set. We must include both cosine as well as of sine term. The function x of t in the interval of t0 to t0 plus 2 by 2 can be represented as x of t is equal to a0 cos 0 omega 0 t plus a1 cos 1 omega 0 t plus a2 cos 2 omega 0 t plus up to an cos n omega 0 t plus b0 sin 0 omega 0 t plus b1 sin 1 omega 0 t plus up to b of n sin n omega 0 t. Now the cos 0 omega 0 t is represented as a1. So that's why I write here as a a0 first, this 2 multiplication. Then after a1 cos 1 omega 0 t plus a2 cos 2 omega 0 t up to an cos n omega 0 t. Because of all it's represented as a orthogonal, but this orthogonal is present for the periodic cases. So the periodic signal cases. So next, then after we have for the sine term, that is b1 sin n omega 0 to this term sin 0 is equal to 0. So then b1 sin 1 omega 0 t up to b of n sin n omega 0 t. So now we got for the orthogonal set condition as a complete set of cos as well as of sine term. That is, it's represented as a both cosine as well as of sine term is present for the our x of t. Now I can simplify for this equation as like a0 is a constant, I take it out, remaining as a1, a2 up to a of n. I write as a simply a of n, then n is present for the 1 to infinity cos n omega 0 t plus this term also b1 to b of n, that is I write as a b of n. It will be take the summation from the 1 to infinity in sin n omega 0 to. So this is the way I can simplify for the equation in the case of trigonometric condition, but in the signal is present say orthogonal with both combine of sine as well as of cosine term is present. But this it will be going to work between the t0 to t0 plus capital letter T. This T I should write as a 2 pi by omega. Okay. So now this t I should consider as a fundamental period of signal. After that, we got for the A0, AN, BN. Those to be represented as a trigonometric Fourier series coefficient. This trigonometric Fourier series coefficient we need to calculate as the condition of orthogonality. Now we studied for the orthogonality in the signal analysis. If we take for the signal as a two different vectors, like this is represented as a V1, this is represented as a V2. So both it will be going to have a different direction is going to work. So now this this lines I represent as a vector. Then the dotted line it will be represented as a magnitude. So the orthogonal signal it consists of vector as well as a magnitude. Here I write as a C1, 2. So because of the vector of V1 and vector of V2, this is a coefficient of vector coefficient between the V1 and the V2. Then it's represented as a V2. So here I represent as a V1 is equal to C1 to V2. This coefficient it's matched with V1 as well as V2. If the signal is represented as a orthogonal, then C12, that the vector coefficient C12 is equal to integration of the interval between V1 as well as V2 is that will be represented as a time. It is a T1 to T2, F1 of t and F2 of t dt. This value I represent as a F1 of t. So V1 is equal to F1 of t, V2 is equal to F2 of t. Now the integration of the time interval between the T1 to T2, F1 of t, F2 of t dt divided by integration of T1 to T2, F2 square of t dt. This based on the F2 only we got for the C12. So that's why we divided for the F2 square t dt integration with T1 and T2. Now in this case what will be going to happen? If the signal is represented as a orthogonal together, then the F2 of F2 square is represented as a unit. Now we come with the trigonometric Fourier series. This trigonometric Fourier series we need to find for the trigonometric first Fourier series coefficient is represented as A0. This is represented as a fully doesn't have any harmonic. It's present for the only amplitude. So that's why this F2 square of t is consist of 1. So here I write as a 1 square dt. So the A0 is equal to integration of as per the trigonometric is we taken for the interval of t0 to t0 plus t. X of t 1 into dt divided by integration of t0 to t0 plus capital letter T 1 square dt. So now the two signal we taken, that is F2 is equal to 1, then here also it will be represented as 1. This is 1 square, here is represented as a 1. So here I represent as a 1, here is a 1 square. Then we need to simplify for this case. So this case if we simplify, if we are going to integrate and substitute the interval, we got for the output is 1 by capital letter T integration of t0 to t0 plus t x of t we got. This term it will be represented as a capital letter T. Okay, so what is it here? I represent for here, that is t in it will be interval of this term only I will write here t0 to t0 plus capital letter T. Then I write as a t0 plus capital letter T minus of t0. These two are getting to cancel. Only is going to have the t. This t only I write for here. That is time period. So this term I should write for the same x of t dt. The integration of t0 to t0 plus capital letter T we should write. Now we got for the A0, that is first coefficient, that is a constant coefficient. Next another coefficient of trigonometric Fourier series E of n. This case the F2 of t is represented as a sine cos term, cos n omega 0 t. As per the case here what we have taken, the one term is represented as a sine, another term is represented as a cos. So both it will be going to a combination of trigonometric series. So now we take one for the F2 is represented as a sine cos domain. So A of n is equal to integration of t0 to t0 plus t x of t cos n omega 0 t dt I write. Here also F2 is represented as a cos n omega 0. That's why integration of t0 to t0 plus t cos square n omega 0 t dt we write. After for this case, I should follow for the trigonometric condition. So we know the case of integration of t0 to t0 plus t cos square n omega 0 t dt is equal to integration of t0 to t0 plus t sin square n omega 0 t dt is equal to t by 2. I should write for this term as a t0 by 2. Then b of n is equal to same like that one. The f2 of t is represented as a sin term. So integration of t0 to t0 plus t, this x term is represented as the input sin n omega 0 t dt divided by integration of t0 to t0 plus t sin square n omega 0 t dt, right? So after simplification of applying for this trigonometric condition, we write as a of n equal to 2 by t integration of t0 to t0 plus t x of t cos n omega 0 t dt, and b of n equal to 2 by t integration of t0 to t0 plus t x of t sin n omega 0 t dt, like that. Now we find for the coefficients. What are the coefficient? A0, En and Bn. For we got what the equation is A0, E of n and B of n. We both it will be represented as a trigonometric Fourier series coefficient. Those things we got it. Now after that we go for the Dirichlet condition for the Fourier series. So this condition, the Fourier series coefficient, it will be going to satisfy for the some condition. Those condition we call for the Dirichlet condition. So this Dirichlet condition going to have the four category. First one is finite number of maximum and minima. So when we go for the integration, the limit is present for the minimum as well as the maximum. For example, we take for the one square sinusoidal signal. So the minimum value equal to 0, maximum value equal to 2 pi. So this sine wave, that is x of t is equal to sine of omega 0 t. This case 0 less than omega less than 2 pi. I should write 0 less than or equal to omega less than or equal to pi. This 0 less than omega less than 2 pi, this value is represented as a minimum, this value is represented as a maximum. This it will be going to continue together after next 2 pi, that is 0 to another 2 pi. That means 2 pi to 4 pi will be going to have the same character of signal. So this is 2 pi to 4 pi. So now this signal only we are going to analyze it for the trigonometric Fourier series. So that condition, the first case, finite number of minimum and maximum. Our interval of the signal is between the minimum as well as the maximum in one period. Okay, I take for the here is a one period. This is one period. The minimum value is equal to 0, maximum value is equal to 2 pi. So one period, the function of f of t must have finite number of minimum as well as of maximum in the meaning of interval of one complete periodic signal. Second one is finite number of discontinuities. In one period, the function f of t must have finite number of discontinuity, and each discontinuity must be as a finite. See, this is one period. This one is 2 pi is a finite value. Okay. So now what we are doing for this periodic, each period for one complete cycle, it consists of finite value. Next case, absolute integrable. The function f of x must be absolutely integrable over a period, meaning that integration of minus 2 to plus 2 f of x must have a finite value. That means we need to find for this one complete signal. What we are doing, we take for the integration. That integration present for the interval of the integration present 0 to 2 pi. That is a one period. After that, we take for the x of t dt. We should write. This is represented as a0. Okay, we represent as a0 divided by 2 pi. So now this t, this based on the t value present by the up to 2 pi. That's why I write as a 1 by 2 pi. The t value is equal to, that is t present by the t is equal to 2 pi. Then as per the a0, I write as a 1 by t is equal to 2 pi. Integration of 0 to 2 pi x of t dt I should write. Okay. Now I write again the A0 it will be represented as A0 is represented as 1 by t. That t is equal to 2 pi. Integration present for the 0 to 2 pi. Then x of t dt we should write. Okay. So that's why the absolute integral case of digital condition, the f of x is a function. It must be absolutely integrable. The limit present for the minus infinity plus infinity. That limit is represented as a period. F of x must have the finite value. Next case, it's a bounded. Okay. So why we bounded? Our signal is going to bounded value. How much is going to happen? 0 to 2 pi. So that's why f of x must be the bounded. That means what we are going to receive the signal is represented as bounded. Okay. And this case, we write for the Fourier series. Here I write for the f of x with a period of 2 pi. Use the variable subscript n is equal to 1, 2, 3, 4 like that one I write. Now I write as a f of x. Here I used for the Fourier series as a x of t. So this x of t and f of t is similar only. Now the f of x I should write a0 divided by 2 plus summation of n equal to 1 to infinity a n cos n x plus b n sin n x. We need to work out the Fourier series coefficient. We find for the a0, a n, b n for given function f of x. This process is broken down into 3 steps. What are the 3 steps? A0 as well as of an, bn. A0 is equal to 1 by pi integration of 2 pi f of x dx. An is equal to 1 by pi integration of 2 pi f of x cos nx dx. Bn is equal to 1 by pi integration of 2 pi f of x sin nx dx. We integrate or over the single interval that will be present for the x is present for the L equal to 2 pi length. If we have the 2 pi length, here I take for the square wave to how it will be going to happen for the 2 pi length. So it will be represent for the vertically jumped for some 0 to some location. This location is represented as 2 pi. I start for the 0 up to it will be going to end for the 2 pi. I used for the this is pi. This pi is represented as 0. This 0 will be going to exit from the upper bound as well as a lower bound. This is a plus bound. This is a plus bound as well as a lower bound. It's have equal. After that, some deviation, it's going to have the saturated. So this saturated, it will be going to happen. What the period is present for the 0 to pi, same period also will be going to taken care of here. So after that, it's going to again it came to 0. It's again it's going to exit for the upper to lower. So this it will be going to happen for the periodically. So now I should take for the 0 to 2 pi what the function is going to happen. It will be going to repeat it for the another 0 to 2 pi. That means 2 pi to 4 pi duration. So this case it will be going to represent as a Fourier series convergence of half wave point as well as a full wave point. This one it will be represented as a half wave point. This duration. Another duration. This is represented as another half wave duration. Both it will be going to add. We got for the fundamental periodic full wave point of Fourier series condition. So next case, the alternative notation of Fourier series I should write for the waveform f of x with period L equal to 2 pi by k. So now why we write for the 2 pi by k? It will be possible to have the so many harmonics are also present. So that's why I should take for the t is equal to k. That case, the Fourier series of trigonometric condition f of x equal to a0 by 2 plus summation of n equal to 1 to infinity a n cos n kx. So here previously we used for the omega 0. Due to that case, I used for the k. That's it. Plus b of n sin n kx. So here also omega 0 we used in the case of periodic condition. This is also periodic, but we use for the another notation is called for the k. So based on this one, I should represent for the our 3 different coefficient of Fourier series of trigonometric condition a0 equal to 2 by L integration of L to f of x dx as well as of an is equal to 2 by L integration of L to f of x cos n kx dx bn equal to 2 by L f of x sin kx dx. The integral are over the single interval x to x is represented as a capital letter L. Next, for the waveform x of x, f of x with period is represented as a 2L. That value I consider as a 2 pi by L. We have k is equal to 2 pi by L. This two getting to this both the two is getting to cancel. Then remaining pi by L's are there. Now in this condition, nkx value is equal to n pi x divided by L. I should write. For this, based on this notation, I should write like this one. So this condition, how to write for the Fourier series using for the trigonometric condition. Then f of x equal to a0 divided by 2 summation of n equal to 1 to infinity an cos n pi x divided by L. So instead of omega 0, we should change n pi x divided by L plus bn sin n pi x divided by L. This condition, what is the Fourier series coefficient? That is an, bn as well as of a0. a0 is equal to 1 by L integration of 2L. There is no changes. There is no changes in the limit. There we are using the L. We are using for the 2 time of L. That's why I will use for the 2 time of L. So f of x dx. an is equal to 1 by L integration of 2L f of x cos n pi x divided by L dx. b of n also will be represented as 1 by L integration of 2 time of L f of x sin n x L dx. The integration are over the single interval on x equal to 2L. Previously, we used for x equal to L. Now, we used for the x equal to 2L time. Why? Because of we are changing for the another notation. Next question. For the waveform f of x with fundamental period, I write as a t equal to 2 pi by omega. This condition, the trigonometric series of Fourier series is f of t is equal to a0 by 2 summation of n equal to 1 to infinity an cos n omega t plus bn sin n omega t. So, this condition, if you write for the a0 is equal to 2 by t integration of t f of t dt, I should write an is equal to 2 by t integration of t f of t cos n omega t dt, we write bn is equal to 2 by t integration of t f of t sin n omega t dt. The integral over the single interval is represented as t is equal to capital letter T. So this is the 3 different way notation we should write for the braces. For here, first condition we taken for the total length of one period is equal to L equal to 2 pi by k. We write for the Fourier series is like this one. Another case, we take for the 2L is equal to 2 pi k. Due to that case, k is represented as pi by L. We write for the trigonometric Fourier series as this kind of notation. The variables, that is trigonometric Fourier series coefficient variable, will be represented for the a0, an, bn, we write. So this case, x of L is x is represented as 2L time. Next condition, we take on for the t is equal to 2 pi by omega. We write the Fourier series is represented as a0 by 2 plus summation of n equal to 1 to infinity an cos n omega t plus bn sin n omega t. So the Fourier series coefficient we write as an, a0, an, bn, all it will be represented for the like this variable we can change it for the equation. And finally we represent as the integration of over a single interval is represented as t of capital letter T. Okay, this is a 3 different way we can write it for the Fourier series coefficient based on the our time interval, whether it be have the L, whether it will be have the T, whether it will be represented for the 2L period. For any condition, we can write for the trigonometric Fourier series case. Next case, we go for the exercise. Now, I received for the signal f of x equal to 1. The interval is present by the minus pi to 0, 0, 0, f of x equal to 0. The 0 to x less than of pi is value is equal to 0 and has period is equal to 2 pi. Okay, this case we need to draw the diagram. First, what will be represent f of x equal to 1. Okay, the signal f of x equal to 1, the period of minus pi to 0. Okay, that is minus pi here, 0 is here. the amplitude value is equal to 1. I should write for this one. This is the amplitude value equal to 1, that red line. Then after it's a 0, the amplitude value is represented as a 0, the interval of 0 to pi. So the 0 to pi, the signal is represented as a case of 0. Okay. Now we can see this complete red lines. What will be happen? This complete red line minus pi to plus pi is minus pi to plus pi. We got for the one signal. This signal, it will be going to continuously going on as the periodic nature. So next case, pi to 2 pi, again it will be going to represent for the this case it became. The next 2 pi to 3 pi, it will be going to hit for this case. So like that will be going to happen for your complete signal. That's why I write for the graph for the interval of minus 2 pi to plus 2 pi. Why? Because of we need for the whether the signal is periodic or not. If the periodic, then the signal is going to satisfy for the trigonometric Fourier series condition. So in this trigonometric Fourier series condition, we should find for the trigonometric Fourier coefficients. First we go for the trigonometric Fourier coefficient. A0 is equal to 1 by 2 pi. Okay. For the alternate notation, what we are writing by the trigonometric Fourier series. So here it will be for all the case. So here this case, what will be we broken for the 1 by a0 equal to 1 by pi 2 pi f of x dx we write. Why? Because of this 2 pi duration. So the signal is going to happen for the 2 pi duration. See here, this is pi to plus pi is represented as a 2 pi, minus pi to plus pi, that is minus pi. It will be started here, then minus of, that is this is minus of plus pi. So what be going to happen for the total period is represents a pi plus pi equal to 2 pi. We write as a 2 pi. So the minus 2 pi to plus 2 pi we drawn the diagram. So this case we followed for the alternate notation formula a0 equal to 1 by pi integration of the limit is here we write as a 2 pi, but we received for the minus pi to plus pi for in our signal. So that's why I should write this value as a minus pi to plus pi f of x dx. Then after this, here is 1, here is 0. We can split. What is the limit? Minus pi to 0 is represented as a 1. As usual, 0 to plus pi is represented as a 0. That's why integration I should split. So this 1 by pi I write it by like this one, minus pi to 0 f of x dx plus 1 by pi 0 to pi f of x dx. So 0 to, that is first case, 0 minus pi to 0 is represented as a 1 as usual, plus 0 to pi I write, it will be represented as a 0. You can write it. Then after you make to integrate, try to substitute. Then after we get for the a0 is equal to 1. Okay. So next case, a of n we need to find. So a of n also will be represented as a 1 by pi integration of minus pi to plus pi f of x cos n x dx will be represented. So this one also the signal will be going to present for the minus pi to 0, 0 to pi, like that one you can split for the your integration to substitute the value f of x value. After that we made for the integration. After integration we got it the output as e of n equal to 1 by pi n pi 0 plus 0 is equal to 0. And the same like that one b of n also we need to find the interval of 1 by pi integration of minus pi to plus pi f of x sin nx dx. Our signal is present for the two cases, 1 as well as sub 0. So the 1 is present for the limit of minus pi to 0. This is 0 to plus pi. Then integration we can split, then substitute the value of f of x. Then after make to integrate, then submit for the interval of both minus pi to 0 and 0 to pi. After that we get it the output as b of n is equal to minus of 1 by n pi minus of minus 1 whole power n plus 1. So this value it's going to differ from the two different cases. What are the different cases? N as well, n is represented as even, n is represented as odd. Two condition it's getting to vary. So here I write, I say b of n is equal to 0, n is even, minus of 2 by n pi, n is odd. Yeah. Now we find for the both a0, d0, an, bn. This is represented as a Fourier series coefficient. We take that Fourier series coefficient to find some substitute for the trigonometric Fourier series case. F of x equal to a0 divided by 2 plus summation of n equal to 1 to infinity an cos n x plus bn sin n x. Now we find a0 equal to 1, an equal to 0, bn equal to 0 for n is even, minus 2 by n pi for n is odd. Then we can take for one tabular case, n equal to 1, 2, 3, 4, 5, 6, like that one is substitute. Then what the n value is in this equation, we can substitute for the, first we represent for the 1, that is equal to minus 2 by pi. Then 2, you can substitute, 2 are getting cancelled, then it will be represented as 0. 3 we can substitute, minus 2 by 5, 1 by 3. 4 is represented as 0. Then 5 is represented as a minus 2 by pi, 1 by 5. So here all even numbers are getting to 0. Whatever may be, what the even numbers are getting to 0. Then after that, we can substitute from the trigonometric Fourier series formula. F of x equal to a0 is equal to represent as a 1 by 2. That is a0 equal to 1. That's why 1 by 2 minus of 2 by pi sin x plus 1 by 3 sin 3x plus 1 by pi sin 5x plus up to till we have the infinity cases. The cos term is getting to 0. Why? Because of the a of n is represented as 0. This term, these all terms are getting to 0. So only it's present for the b of n as well as of a of 0 term only going to present. This is represented as a what we are going to receive the signal of Fourier series. The series signal is represented as f of x equal to 1, f of x equal to 1, that is minus pi less than of x less than of 0, 0 plus 0 less than of x less than of 5. So this Fourier series of trigonometric condition is represented as a 1 by 2 minus of 2 by 5 sin x plus 1 by 3 sin 3x plus 1 by 5 sin 5x plus up to it will be have the infinity. Next case, I should take for the f of x equal to 0, that is minus pi to 0 of x is represented as a 0, but x is represented as a 0 less than of x less than of pi and has period is 2 pi. First we need to draw for the graphical representation of what we have received for the mathematical formula. Then that mathematical formula, what will be happen when minus pi to plus 0 is represented as a 0 only. Minus pi to 0 is represented as a 0. Now that is minus pi here up to 0, it's represented as a 0. Then after, what will be happen? 0 to pi, it's represented as a x value. So that means if you have 0, 0, if you have here is represented as a some value 1, 1, 2, 2, 3, 3 up to 5, the value is represented as a 5. The amplitude is equal to pi. Then after you can join for all the values. So what you are getting? We get for first minus pi to 0 is a 0. Then after it will be going to get for the ramp signal. When you reach pi, automatically it's represented as a 0. Okay. After that again next sequence is going to start for this one. Then pi to 2 pi is 0. Again it will be going to increasing for the ramp signal up to the amplitude of pi. After that it is represented as a 0. Now this will be continue for minus direction to plus direction, both the direction. That's why I take for the minus 3 pi to 3 pi duration to draw the waveform. Then this case we need to find for the Fourier series coefficients. What the Fourier series a0, an, bn based on the interval. From this equation a0 is represent for the 1 by pi integration of minus pi to plus pi f of x dx. This will be have the two different of amplitude of this waveform. Here is 0, minus pi to 0. Then this value it's represented as a ramp signals. Okay. So that value is represented as ramp signal will be going to reach up to pi. We take for the integration 1 by pi integration of minus pi to 0 f of x dx plus 1 by pi integration of 0 to pi f of x dx. then this value is represented as a 0. Here I substitute for the 0. Here is represented as x. So then we make to this portion, entire portion is represented as 0. Remaining portion only is going to have here. If we x divided, that is x square by 2. We should substitute for the 0 to pi of the limit. Then finally we got a0 is equal to pi by 2. And the same like that on b0 also we need to find. B of n as well as of a of n also we need to find. A of n is equal to 1 by pi integration of minus pi to plus pi f of x cos nx dx. Then we substitute for the limit minus pi to 0 as well as of 0 to pi. Both it will be going to have. You can do for the integration after substitute the value. Then we do for the integration. We get it for the equation as a, this case is represented as a integral substitution method we followed. Then that value is represented as a, this portion is represented as 0. We don't want to calculate. Then this portion only we need to calculate. So here is integration substitution equation we used. That will be going to give for the output is like this form. Then after again we do for here is integration. After that you can substitute for the interval of 0 to pi. Then after you can simplify. Then we got for the output as a of n is equal to these values. After substitute for the all limit. Then 1 by pi n square minus 1 whole power n minus of 1. So this case when you substitute for the even number, we got a of n equal to 0. When you substitute the odd number, we got minus of 2 divided by pi n square we got. Next case, we go for the b of n. Another Fourier series coefficient is b of n. 1 by pi integration of minus pi to plus pi f of x sin x dx. So this is also other two different type of interval, that is minus pi to 0 is represented as 0. Then plus pi to pi represented as x. So this portion we can substitute, then it will be represented as 0. Then after you can use for this portion, use for the integration substitution method. Then after you substitute for the interval of 0 and pi, we got for the b of n is equal to minus of 1 by n minus 1 whole power n. So this case also when n is even, minus of 1 by n. If n equal to odd, that is plus of 1 by n we got. Okay, we write for the Fourier series of trigonometric condition f of x equal to a0 by 2 plus summation of n equal to 1 to infinity a n cos nx plus bn sin nx. Then a0 we find and then an and bn is find. Then we make it for one tabular column. The n values represents 1, 2, 3, 4, 5, 6, 7 up to you can take for the infinitive an. So when the even, that is a odd number, it be represented as a 2 by pi. This n value is equal to 1. Then even number is represented as 0. Next case, that will be represented as a odd number. This odd number, the n equal to 3, then 1 by 3 square into minus of 2 by 5. The even number 0, then odd number for 5 minus of 2 by 5 into 1 by 5 square. So same like that one, b of n also it will be represented as a, if we 1 for here, that will be odd number 1 by 1 equal to 1. If you have the even number for the b of n, as the formula of this case, minus of 1 by 2 because of minus of n. Okay, then odd number it's represented as 1 by n, that is 1 by 3. So even number minus of 1 by 4, odd number 1 by 5 like that. Up to you can take for any numbers, that is 6, 7 up to it's other infinitive, because of our limit is present for the minus 1 to plus infinitive. Then after we should substitute for the value of a0, a1, a2, a3, b1, b2, b3 like that. Then after we can simplify. We got for the output like this one, f of x equal to pi by 4 minus of 2 by pi cos x plus 1 by 3 square cos 3x plus 1 by pi square cos 5x up to infinity plus sin term sin x minus of 1 by 2 sin 2x plus 1 by 3 sin 3x up to the beginning. This is the output of we received from the equation or waveform of this one. Okay. So that is f of x equal to 0, limit minus pi less than of x less than of 0, x is represented as 0 less than of x less than of pi. We got the output is like this one. Okay. So then next case, we take for the another case f of x equal to x 0 less than x less than of pi then we write for the pi, then that will be present for the pi less than of x less than of 2 pi. Okay, it's a fundamental period is equal to 2 pi. So first we draw the graph. So it will be have the x, its increase for the 0 to pi. Okay, 0 to pi. So I take for the pi, that will be represented as a 0 to pi. Here is a 0 to pi. What will be happen? It's increase for the ramp signal. Okay, it increase for the ramp signal. After that, the pi to 2 pi, the amplitude is equal to pi. Here I write for the pi. Okay, so this signals. So 0 to 2 pi will be next. The case that is 0 to 2 pi, it will be up to 3 pi. It's represented as a ramp. After that, it's a constant up to it will be represented as a 4 pi. It will be, it's continuously is going to happen. No, this signal we consider as a periodic signal. It is suitable to do for the trigonometric Fourier series. Based on this signal, I should find for the trigonometric Fourier series coefficient, that is A0. As for the interval, we find for the A0 is equal to 3 pi by 2, and A of n is represented as a 1 by n square pi minus of 1 whole power n minus of 1. This case, if odd number, n is odd number, A of n is equal to minus 2 by n square pi, the even number is equal to 0. And same case, B of n also we find the trigonometric Fourier series. B of n also we find. We should apply for the limit based on the input what we have received. Then we make to integrate. Finally, we got for the B of n is equal to minus of 1 by n after substituting for our limit. Then we may write for the trigonometric Fourier series f of x equal to a0 divided by 2 plus of n equal to 1 to infinity a n cos n x plus bn sin n x. So now we can substitute for the a0, an, bn. So first we make it for the tabular column, that is n 1, 2, 3, 4 up to we have the infinitive an. An is equal to, when the even is equal to 0, when odd value is equal to 1 by n square by 2 minus value. So n equal to, this is a odd number. So n equal to 1, that's why minus of 1 by pi. If n equal to even 0, n equal to odd, next number 3, minus 2 by pi, 1 by 3 square. Plus, next, even number 0, 5, that is represented as an odd number, is minus 2 by pi, 1 by 5 square. So here, B of n is equal to minus of 1 by n. So the n equal to 1, that is equal to 1, minus of 1. N equal to 2 is represented as a minus of 1 by 2. N equal to 3, minus of 1 by 3. 4, minus of 1 by 4. N equal to 5, minus of 1 by 5. Now we can substitute for the values of our trigonometric Fourier series. So A, that is A0 equal to 1, that is 1 by 2. A0 equal to 3 by 5 plus minus 2 by 5. The cos of x plus 0 cos of 2x plus 1 by 3 square cos of 3x. That will be up to infinity. What we are going to finding the coefficient is substitute. Then sin term also, it will be take it out for the minus 1. That is sin x plus 1 by 2 sin 2x plus 1 by 3 sin 3x up to infinity value. Finally, I concluded for this equation. This is 3 pi by 4. This is 3 pi by 2, that is denominator 2 is that will be 4 minus of, I take it out for the 2 pi by pi, that minus value also take cos x plus 1 by 3 cos 3x plus 1 by 5 square cos 5x plus up to till we have the infinity minus of sin x 1 by 2 sin 2x plus 1 by 3 sin 3x up to we have the infinity. This is represented as a Fourier series of what we have received from the signals. Next, another case. I take for the f of x equal to x by 2. The interval, it will be going to happen for the 0 to x 2 pi as the period of 2 pi. First, we must draw the graphical representation of what we have received for the signal. The f of x equal to x by 2. So, the interval is up to 0 to 2 pi. When 0, it will be x by 2. Okay, if you say, for example, I take for the 1. Okay, 1 by 2. 1 is equal to 1 by 2. 2 is equal to, it will be represented as a 1, 3. So up to how much is represent? Up to it will be have the pi. After that it will be have the decrease. Again it will be going to increase, decrease. Then we got for the ramp signals. For this equation, we got for the ramp signal. These ramp signals we need to find for the trigonometric Fourier series coefficients A0, AN as well as Bn. So A0 based on the interval, based on the what we are going to receive, the A0 is equal to pi by pi. E of n we should substitute for the interval as per the what you are going to receive the signal, that is f of x cos nx dx integration of 0 to 2 pi 1 by pi. We got for E of n is equal to 0 after substituting the interval. After that we find for the B of n. You take for the B of n equation, that is 1 by pi integration of 0 to 2 pi f of x sin nx dx. Substitute for the limits what the values are present. Then after that make the integration to substitute for the intervals. The interval it will be present for the 0 to 2 pi. Finally we got for the B of n is equal to minus 1 by n cos 2nx. If 2nx is even, okay, if the nx is, that is n is even, we got for the B of n is equal to minus 1 by n. After that we should substitute for the trigonometric series of all coefficient A0, AN as well as Bn. Finally we got the output for the trigonometric Fourier series as f of x equal to pi by 2 minus of sin x plus 1 by 2 sin 2x plus 1 by 3 sin 3x up to we have the infinitive. But the a term all it will be represented as 0. For another example, I should take f of x equal to pi minus of x, the interval between the 0 less than x less than of pi. 0 is represented as pi less than of x less than of 2 pi and has period is 2 pi. Now we need to draw for this graph. Okay. First what will be happen? 0 to pi, the values present for the pi minus of x. If x equal to 0 for here, what is that? Maximum is represented 0. The x equal to 0. Now x, how much you are going to increase? Automatically these values are getting to reduce. That's why it will be represented by the triangular ramp signal. That value up to will be present by the pi. Next case is up to pi to 2 pi is a 0. Next it will be have the pi 2 pi to 3 pi. That here is represented as a 3 pi. Here I make to represent by the 3 pi. This is here we have the up to 3 pi. We have the here is suddenly is increasing up to pi. Then after that decreasing. Like this one we are going to continue both negative as well as a positive direction. Based on this waveform interval, we find for the A0. The A0 is equal to pi by 2. A0 is equal to pi by 2. Next, A of n is represented as here. A of n is represented as minus 1 by pi n square minus 1 whole square minus of 1. So this case when n is even, the A of n is equal to 0. When n is odd, the A of n is represented as 2 divided by pi n square. In same like that one, we should find for the B of n also. You know the B of n formula in the trigonometric Fourier series 1 by pi integration of 0 to 2 pi f of x sin nx dx. We should substitute for the interval and we substitute for the value of f of x and take the integration and substitute the interval. The finally we got for the B of n is equal to 1 by n. Now we find for the A of n, B of n, A0 in the trigonometric Fourier series condition. We make to draw the table, that is n value 1, 2, 3, 4, 5, 6, 7 like that. A of n equal to 2 divided by pi n square. B of n is equal to 1 by n. When A of n, when the odd value only is going to reflect. So the odd value n equal to 1, the A of n equal to 2 by pi, B of n is equal to 1 by n, 1. Then n equal to 2, A of n is represented as 0 because of that will be represented as an even value. B of n is equal to 1 by 2. So then n equal to 3, the A of n is represented as a 2 by 3, 2 by 5, 1 by 3 square. But B of n equal to 1 by 3. Then 4, n equal to 4 is represented as a even number. It's a of n equal to 0, b of n equal to 1 by 4. The 5, 2 by 5, 1 by 5 square. Here b of n equal to 1 by 5. So these values we need to substitute for the trigonometric Fourier series for both a0, an and bn. Then after we simplify for this equation, we get for the f of x equal to 1 by pi, that is pi by 4 plus 2 by 5 cos x plus 1 by 3 square cos 3x plus 1 by pi square cos 5x plus up to it will be have the infinity. Then sine term, sin x plus 1 by 2 sin 2x plus 1 by 3 sin 3x plus 1 by 4 sin 4x up to it will be going to have for the infinity. The next example, we take for the f of x equal to x, the interval present for the minus pi to plus pi and has period is 2 pi. So based on this received signal f of x equal to x, we draw for the graphical representation. See, if we minus of pi, the x also will be represented as a minus value. So here is a minus 5. So if you have the minus pi, you are going to substitute. It's getting for the amplitude as minus pi. This is plus pi. This is represented as a minus pi. We get for the minus pi here. Okay. So then, if we going to increase minus values, automatically the values are getting to increase. If 0 for here is represented as x equal to 0, then the amplitude value is also 0. If we increase for the pi value, then automatically this one also increasing up to where the plus pi. After that it's reached for the 0. Okay. After that it's reached for the 0. Here also be represented. So then this it will be again, if 0 automatically it's represented as a minus pi, then it will be going to increasing together. It will be going to happen like this one. So all the value will be going to get for the like this signal. Now based on this signal, we need to find for the Fourier series coefficient of trigonometric condition. So you take for the a0, we know the formula 1 by 5 integration of minus pi to plus pi f of x dx. The f of x is represented as x. You should substitute here, then make to integrate to substitute for the interval. Then after we get it for the output as a0 is represented as a 0. Then based on that one, we need to find for the a of n. A of n is equal to 1 by 5 integration of minus pi to plus pi f of x cos nx dx. Then substitute for the f of x value, make to integrate, then substitute for the interval minus pi to plus pi, we get a of n is equal to 0. If which condition a of n equal to 0? Since sin of n pi is equal to 0. Due to that condition, the all values represented as 0. So the a of n is represented as 0. Next we go for the b of n. Another trigonometric Fourier series coefficient is represented as 1 by 2, 1 by 5 integration of minus pi to plus pi f of x sin nx dx. So the sin f of x is represented as x. You should substitute, then make to integrate, then substitute the interval. Then finally we got for the output of b of n is equal to minus of 2 divided by n minus of 1 whole power n. So this value is e of 0, e of n, b of n. You substitute for the trigonometric Fourier series for this equation. The f of x equal to a0 divided by 2 plus summation of n equal to 1 to infinity a of n cos n plus bn sin n. So if we need to substitute this case, because of this will be present for the 1 to n, we make it to do for the tabular column. N equal to 1, 2, 3, 4, 5, 6, 7, 8 like that one. B of n, a of n is represented as a 0. No need to calculate. B of n is represented as a minus 2 by n minus 1 whole power n. That means n equal to 1 is represented as a 2. N equal to plus 2 is minus 1. N equal to 3, 2 by 3. Then these values are going to substitute for the trigonometric Fourier series coefficient condition. What will be going to happen for the f of x? The f of x is equal to 2 sin x minus 1 by 2 sin 2x plus 1 by 3 sin 3x. These values are got. Next condition. I take for the f of x equal to x square. over the interval it's between the minus pi less than or x less than or pi, and as period is represented as 2 pi. This value we need to draw the graphical representation. The maximum value, how it will be going to represent? If we have the 0, okay, if we have the 0, take first 0, x equal to 0, the x square also will be represented 0. If we increase further, if we increase as well as a negative as well as a positive direction, we should get for the f of x as a mod value of both minus as well as a plus direction. That means minus pi to plus pi we take. So what we are going to get for this here, the curve, same like that we are getting for this curve. Okay. So this will be going to repeat it for all durations, 0 to pi and pi to 2 pi, pi to 3 pi. So from this equation, this is a waveform of our periodic signal condition. So based on this one, we need to find for the Trigonometric Fourier series coefficients. What is that? A0. A0 is represented as 1 by pi integration of minus pi to plus pi f of x dx equal to 1 by pi. This value x square dx. If we make to integrate for this one, to simplify, we got for the value of 1 by pi 2 pi cube divided by 3. So now E of 0 equal to 2 pi square divided by 3. Same like that, we find for the E of n also. The 1 by pi interval between minus pi to plus pi f of x cos nx dx. So the f of x is represented as x square. Make to do for the integration and substitute for the interval. We got the output of E of n is equal to minus 2 by n pi minus of 2 pi by n minus of 1 whole power n. So this case we have for the n is even as well as of n is odd. E of n when the n is even, we got 4 by n square, but n is odd minus 4 by n square based on the E of n. Same like that one we find for the b of n also. The b of n is equal to 1 by pi integration of minus pi to plus pi f of x sin nx dx. We should substitute for the f of x, then after we make to do for the integration. After integrate, substitute the limit, we got for the b of n is equal to minus 2 divided by pi n square integration of pi to minus pi sin n x dx. This value is represented as 0, b of n equal to 0. Then after you can substitute for a0, an as well as a bn. Then if you need to substitute, we go for the tabular condition because of n is going to vary from 1 to infinity. So a0 is equal to 2 pi square by 3, an is equal to 4 by n square, n is even. If n is odd, minus 4 by n square, but b of n is equal to 0. Then I should calculate for the a of n only. 1 if we represent 1 minus of 4, a of n is equal to minus of 4. If we represent 2, the n equal to 2, 4 into 1 by 2 square, 3 minus 4 into 1 by 3 square, 4 into 1 by 4 square. This value is to substitute for the trigonometric Fourier series condition. So all d of n values are 0. I write here. E of value, that is 1 by 2, E of n 0 is equal to 2 pi square by 3 minus of 4 cos x minus of 1 by 2 square cos 2x plus 1 by 3 square cos 3x minus 1 by 4 square cos 4x up to it will be have the infinity. Finally, I can simplify. The equation is represented as f of x equal to pi square by 3 minus of 4 cos x minus of 1 by 2 square cos 2x plus 1 by 3 square cos 3x minus of 1 by 4 square cos 4x. Up to this much we received for the signals. Now this case we received for the waveform. So here I received for the waveform as a full wave rectifier. But this waveform, based on this waveform, we need to convert for the equation. Okay. So here obtain the Fourier series of following full wave rectifier sine wave shown in the figure. So now the x of t is equal to x of minus t. For given signal is even signal. So b of n equal to 0. Then t value is equal to 1 period, that is equal to 1. The t value is represented as a 1 period. We represent as a 1. So omega 0 is represented as a 2 pi by 1. Okay, we know that is omega that is 1 log omega 0 is equal to 2 pi by capital letter T. T value is equal to 1, that is 2 pi by 1 equal to 2 pi. I found for the T value as well as the omega 0 value, that both we found. Based on this condition, we write for the equation. The given signal I write as a x of t is equal to a sin omega t. So now we need to find for the omega, that omega is equal to 2 pi by t. We studied. So here what the interval? So 2 pi by t in the sense 0 to 2. One complete cycle in the sense 0 to 2. Now this variation is represented as a 2. But the previous case here, we taken for the this signal will be going to repeated for the another cycle also. Both the characters are similar. That's why this t is different, this t is different. Omega 2 t is different, omega 0 t is different. Omega t is equal to 2 pi by t, 2 pi by 2 equal to pi. Now I consider say a is equal to amplitude is equal to 1. Okay, a amplitude, this value is represented as 1. Now finally I wrote x of t equal to sin pi t. Okay, x of t is equal to sin pi t. Now we should evaluate for the a0, that is a trigonometric Fourier series a0, an and pn. a0 is equal to, we taken for the only half cycle. So that's why 2 by t, integration of 0 to t by 2. Okay, this interval is represented, totally is represented as t. Then I write as a 0 to t by 2, that is t by 2, then t by 2 to t. Okay, this interval will take 0 to 2 by t by 2 x of t dt. So now we can integrate and substitute the value. Finally we got for the a0 is equal to 2 by pi. Then after we need to find for the an. This an is equal to 4 divided by 2. Why? Because of two signal we have taken. Okay, this two signal. We multiply for that two signal. Then we got for the 4 by t, integration of 0 to capital T by 2 x of t cos n omega 0 t dt. Here 4 divided by 1, integration of 0 to 1 by 2 sin pi t cos n 2 pi t dt. So we should take, this is sin A sin B condition. We write for the sin A sin B equation. After that we do for the integration, substitute the interval of 0 to 1 by 2. Then after finally we got for the a of n is equal to 4 divided by pi 1 minus of 4n square. So b of n automatically is 0. Okay, there is no negative terms are present here. So here we got for the b of n equal to 0. So then after we substitute for the a0 as well as of an b of n. So this term entirely getting to 0. B of n terms is 0. Only these terms are there. The a of n we know 1 by pi 1 minus of 4 n square. A0 is equal to 2 by pi. Then finally we got the equation for full wave rectifier as x of t equal to 2 by pi plus summation of n equal to 1 to infinity 4 divided by pi 1 minus of 4 n square cos n 2 pi. Then these are the topic. Those topic I am going to refer from the signals and system and communication B at the 2013 BSP publication, and AV Opnum. The second I followed for the second edition. It's published for the 2010. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.